Hello students, welcome to my channel, Easy Physics by Visualization. Today, we are going to discuss about crystal lattices. In this video we will discuss about crystal lattice, basis, translation vectors, and angle between them. Augusta Brava assumed that a crystal is made up of a three-dimensional array of points, such that each point is surrounded by the neighboring points, in an identical way. Such an array of point is known as Brava lattice, or space lattice, or point lattice. In the simplest crystal, such as copper, silver, sodium etc., there is a single atom, or ion, at each lattice point. More often, there is a group of several atoms, molecules, or ions, at each lattice point. This group is called the basis. The crystal structure is obtained by placing the basis on each lattice point, such that the center of the basis coincide with the lattice point. If we repeat the basis with correct periodicity in all directions, we get the actual crystal. The transition vectors, vector A, vector B, vector C, of the lattice, define the crystal axes. To generate the lattice points, in space, we chose three basic units vectors, along three coordinate axes, of the rectangular coordinate system x, y, z, and then, translate these vectors, along the respective axes. Let the lattice points, in the x, y, and z directions, be repeated, at an interval, a, b, and c, respectively. The vector A, vector B, and vector C, are called the basis vectors, or fundamental translation vectors, or crystal axes. The position of any lattice point can be represented by a vector, t, such that t equal to n1a, plus n2b, plus n3c, where n1, n2, n3 are integers, and t is the lattice translation operator. Here we have taken translation vectors along x, y, and z axes. Let alpha, beta, and gamma be the angle between the translation vectors. Sum of the representation of translation vectors shown here. If n1 equals 1, n2 equals 1, and n3 equals 1, lattice can be represented as similarity. If n1 equals 2, n2 equals 1, and n3 equals 1, lattice can be represented as if n1 equals 2, n2 equals 2, and n3 equals 2, lattice can be represented as in these cases, the angles alpha, beta, and gamma is equal to 90 degrees. The angle between these vectors need not be 90 degrees, they can have any value. Depending upon the magnitude of the fundamental vectors, need not be 90 degrees, 7 different crystal systems are possible. Details of different crystal structure, we'll discuss in the next video. Depending upon the magnitude of the fundamental vectors, and the angle between them, 7 different crystal systems are possible. Details of different crystal structure, we'll discuss in the next video. Thanks for watching.